Let us have a look at the different types of data structures. And in this video, we get a conceptual view of the simplest of data structures, namely the arrays. Then we will be able to differentiate what is a logical view and what is a physical view of a data structure. Let us recap what we mean by the word data structures. The data that we are storing is stored in the primary memory or the RAM, and the major objective of the data structure is to store the data in an orderly manner in the memory so that when we perform an operation on the data, operations like insertion, deletion, searching or sorting, the performance of the algorithm is at its best. There are many types of data structures based on how the data are stored and what the operations allowed on the data are. I want you to execute the following code and say what will be the output of the following code. The whole code is written in C. The size occupied by an integer is printed. The size occupied by a pointer or the number of bytes required to store a pointer is printed. And then space is allocated for 9 integers. When executing in the 32-bit version of the code blocks, the size occupied by integer was 4 bytes. A pointer variable took 8 bytes. And so the size of int star and the size of array A are one and the same as 8 bytes. Let us allocate space for 5 lists. When I say the term list, I mean to say that there is more than one element in that list. So when I say the term A is a list and I am storing 4 integers in it. B is a list and I store 6 integers in it. C is a list of 3 elements. D is a list of 16 elements and E is a list of 12 elements. The space is allocated using malloc function in C. In the list A, one integer occupies 4 bytes, and like this list has 4 elements. So the total space required to store A is 16. Similarly, B takes 6 into 4, which is equal to 24 bytes of space. C takes 12 bytes of space. D takes 64 bytes of space, and E requires 48 bytes of space. To simplify explanation, the memory is shown as composed of many blocks. Each block is composed of 4 bytes of space. So, to store the list A, we require 4 blocks. And the 4 blocks are represented as A1, A2, A3 and A4. 6 blocks are required to store B, and let us assume that malloc allocates it in the next free space, which is immediately after A. So B takes 6 blocks of space. Similarly, C takes another 3 blocks of space. D takes another 16 blocks of space. And E takes up 12 blocks of space. Now let us free the space which was allotted for B and D. When we remove the 6 blocks that were allocated to B, we get some free blocks in between A and C. And when we remove the space allocated for the 16 blocks of D, we get another free space between C and E. We had a list A, it required 4 elements, and we gave it in continuous spaces in the memory. And then we had another list D, which required 16 spaces, and we gave it in continuous spaces in the memory. What is the name of this data structure? When we store similar data items in contiguous memory locations, the data structure that we use is called as an array. And the operations that are allowed on an array are insertion, deletion, of course you can perform a searching, sorting, and even rotation of the elements in the array. I have given a snapshot of the memory. Remember, the elements in A should be stored in contiguous locations. It is not essential that list A, list B, list C and so on should be in contiguous locations. The elements of one single list need to be in contiguous locations. A snapshot of a memory is shown. How many arrays do you see? Assuming that each array is given a different color coding and the black colored blocks are the free spaces. Initially, when the lists were being stored in the memory, I showed as if B is allocated in the space immediately after A, C is allocated in the space immediately after B and so on. But in reality, all the elements of A are stored in contiguous locations, but A, B, C, D, E need not be in contiguous locations. Now, assume that we need another list called as X and it requires 11 blocks or 11 elements. To store 11 elements, which are integers, it requires 11 into 4, which is equal to 44 bytes. And so, when we use an malloc statement, it is going to look for 11 blocks. When I try to allocate space for X, I find that I cannot find 11 contiguous blocks of space, but I have free blocks here and there. So is it possible for me to allocate 4 blocks of memory immediately after A where I find a free space and the remaining 7 blocks further down in the memory? Can I allocate space like this? In reality, an malloc looks at the entire list as an array, and if it cannot find contiguous blocks of space, you cannot allocate space for the 11 blocks. An array requires that the elements of the array are in contiguous memory locations. Another way that we can look at it is, let's say you have an array, most of us are used to the concept. If I access the first element as I, if I use a pointer, the second element I would access it as I++. If the first element is at the location 100, the minute I say I++, the compiler knows that the next element is found at the location 100 plus 4, which is 104. But what would happen if they are not in contiguous locations? If it is not at the plus 4th byte, does it know it suddenly has to jump 100 bytes to go to the next location? It is not possible for the system to know it. It violates the entire definition of an array. When you use an array, compulsorily, all the elements of the array require contiguous memory spaces. If there is no contiguous memory spaces, you cannot allocate space for the array. Now, what's the difference between saying something to be contiguous and continuous? Whenever we use the term memory, the memory is composed of many contiguous locations. It looks more like the chair on the left hand side than the bench on the right hand side. I can have 5 people sit in different chairs but next to one another. I can have 5 people sit in the bench one after the other. If the 5 elements occupy multiple contiguous locations, it is termed as contiguous. We just saw how it is actually stored in the memory. Physically in the memory, it starts at a particular location and it ends in a particular location. But when we say the logical view, we simply look at it as a list of elements that are found one after the other, and the name of the array represents the starting address of the entire list of elements.